Question 1, call 1, simultaneous equations. Let's press pause. Let's write this question down. Let's find x and y. Press play when you are ready. Now this question is a typical basic style question on simultaneous equation. And let's look at this. It's a bit tougher than the back to basic question we had previously. Now the first thing, let's label each one. Let's identify them obviously and label them number 1, number 2. What is the value of x and y in both of these linear equations? Now the first thing, let's look at the variables. Which ones can we identify with the same sort of number before that? Now when we say same, we don't mean exactly the same, but it could be a difference in the sign. One could be a plus, one could be minus. It's definitely going to be the y variable over here. We have a +2 and a -2 on the y variable. Let's circle this. This is what we want to do. So we want to eliminate the y variable over here. Let's decide now how we could do that. Do we put a plus, 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 or minus, minus, minus in between them? Now, it'll be a plus because plus 2y plus minus 2y is going to be 0y. We'll put that over here just so you understand this. Because a minus and a plus, so plus and a minus in this case, will make 0y. Any sign that's different, by the way, a sign change over here, is going to be a plus. So this is plus, and this is plus as well. Let's plus all the 3 columns respectively. 3x plus 4x, this is going to give us 7x. And 2y plus minus 2y will give us / or 0y. 8 plus 6 is going to give us 14. X is simply going to give us an answer of 2. So x is 2. Let's do the second step now. Let's sum this into the easiest linear equation. This will probably be number 1 because it's simply got a positive coefficient of 2 here. So wherever we see x, we're going to sum in 2. So this is 3 times x. I'm going to write 3 times 2 over here. Plus 2y equals 8. So 6 plus 2y equals 8. 2y equals 8 minus 6. Look how we did that. The plus 6 becomes a minus 6. And therefore, 2y equals 2 and y equals 1. You can always test this if you want to in number 2. 4 times 2 is 8. Let's try to check over here. You don't have to do this. If you have spare time, it's definitely worth it. If x is 2, 4 times 2 is 8, minus 2 times 1, because y is 1. We should get 6. So this is 8 minus 2. It's 6. And this is 6, obviously, over here. So that's how you do this basic style simultaneous equation. Question 1, call 1, sampling. So press pause, write this question down at part A and B. This is a foundation tier or high tier question. Grade 5 and the 3 marker. Press play when you have completed this. Now the table below shows information about the favourite subjects of a Year 11 form class. So here we have 4 different subjects and the respective pupils that like these subjects. So maths 11, English 7, science 8, geography 4. Okay, there are 1,200 pupils in the school altogether. So by the way, when we go through this question, we're going to just pick up a few key, let's say, numbers. We're going to highlight this purple. It will become quite apparent why we're highlighting this in a second. Lily wants to know how many students' favourite subject is maths within the whole school. So let's work this out. So she wants to know basically if you had this sample, which you do over here, and if you picked, let's say, the 11 students from over here out of the whole sample size, which is going to be 11 plus 7 plus 8 plus 4, that's 30. That's our sample size over here. What number would best represent those students that like maths out of 1,200, i.e. how? Well, there's 11 out of 30 represents something over 1,200, okay? That's the question. Let's think of it like this. We'll put this in orange as well, by the way. So we're going from a sample to a population. We'll call this sample, and we'll call this population over here. Okay, sample means a small selection of data. Population is the whole entire school. So in a color-coordinated version, this 11 would represent this, sample X, and the sample total would be, let's say, the 30, which would be the orange bit. The population is what we want to find out. Well, let's call this red over here. Okay, it's like, this is the question that they're trying to pose to us. And this is the population total, or we sometimes call it P. It's really big, like over here. You know, you can color this in all over like this. Okay, so this is basically what we're trying to do over here. Find the red dot. This is a visual representation, how we get from sample to population. And what they've given us already is this. They've given us 11, okay, it's out of 30. We want to find out x over here, and this is 1200 over here. Okay, hence that's why we colored in everything over here. So the formula would be this one, from sample to population. I'll write this down actually over here. Sample to pop for short. Okay, so it's sample x over sample total times the population total. All right, and sometimes we call it dash p. Okay, but you don't have to. This is 1200, by the way. Okay, so let's do this. Let's plug in the numbers, and it may help you if you just color code these once again. That's the yellow one. This one is the orange one over here. And this is the purple one over here. Once you understand this formula, we don't have to go through this process ever again, just so you understand the basics of why a sample is a good representation of a population. So 11 over 30 times 1200. This is non-calculator. Let's put a 1 underneath there to make them two identical fractions. Let's see now what goes to 30 and 1200. Okay, that's a much quicker way of doing it. The factor is 30, so we divide them both by 30. It's 11 over 1 times 40 over 1. We've got 40 because 40 times 30 is 1200. 11 times 40 is simply 440. So 440 is actually this over here. Okay, this one, 440, is actually what this is going to be represented by. The total amount of pupils that enjoy maths in the whole school. Okay, so make sure you understand that, and that is the same thing as the red one over here. State any assumptions you have made during this calculation. Well, we assume, as we keep saying, that the sample size of this 11 over 30 is a good and fair and unbiased representation of the population. Okay, so 11 over 30 is like an equivalent fraction of 440 over 1200. These 440 were probably all like maths if you took them all from the whole school, i.e. 1200. So somewhere and somehow you've got to write that in your answer. Okay, but the key bits are basically the sample is a fair representation of the population size. All right, so that's the key word you really want to look at, the fair representation. And also all factors would stay the same, majority of them, when you go from the sample to the population. Okay, this left bit over here to the bigger right bit. So write this question down, press pause, press play when you are ready. So this question, we're dealing with two separate, let's say, accounts. One a cash account, one a shares account. Shares means stocks and shares. And this could definitely be something from the real world. So let's see what numbers we have over here. Okay, we have £3,000. This is being invested by Kobe in both bank accounts. Now, which one will give him the best rate? Now, this is something called comparisons. It comes up quite a lot, in fact. So let's look at the cash account. We get 3.5% a year here for 4 years. And this one, the shares account, is called a multi-step problem, multi-interest, let's say. It's 4% in the first year, 5% second and third. It's higher in this latter years just for customer loyalty. This is how banks operate, actually. So it's a real-life example. So what should he actually invest in, considering all other factors are the same? We're just looking at the monetary value at the end to analyze this investment. So the cash account, let's see. So what we'll do is this. We'll do 3,000 times 1.035, very simple, to the power of 4. So it's our basic setup using our three key numbers over here. Nothing difficult in that. And the answer is £3,442.57. So that's how much Kobe would make in his first, the cash account. Now, what about is a bit more risky? Let's say he wants to invest in the stocks and shares account. Okay, so he does this. Kobe invests £3,000. Now, he invests in the first year, he gets 4%, 1.04, a bit more for your money because obviously it's a bit of a higher risk. Now, 5% in the latter 2 and 3 years. Now, instead of writing 1.05 times 1.05, we'll just write 1.05 squared, okay? Because at 2 years, it'll save you a bit of time. So this answer will be £3,439.80. That's how much it'd make over there. Okay, So let's obviously look at this and then base this investment just on the monetary terms. You shouldn't really in real life, but we'll just do it in this case. And which one is obviously higher? 3,442 or 3,429 is obviously the cash account, okay? Because obviously it's the last year that's made it in the 4th year. So we're going to go with this one over here, and this is our final answer over here. Okay, so we would invest in obviously the cash account. Let's just write that to make it a bit more clearer. Cash. Okay. Basic surface area. Press pause, write path A and B down on a piece of paper. Let's try to attempt this question all about cubes, and press play when you're done. Let's read the question over here. So the volume of a cube, the cube over here has the same dimensions, obviously, you know, height, width, and depth, is 512 centimeters cubed. Find the surface area of this cube. So we're trying to just basically interpret this question into two different ways, and two different dimensions. One dimension is volume, and the other dimension is surface area. You should be confident in going from one to the other and vice versa. In this case, it's going to be volume to surface area. Let's think about this question over here. First of all, let's draw this cube. It's always good to draw a cube to visualize it. Let's see over here. This is how we draw a cube. Okay, 3D cube, not bad, huh? So now this cube, obviously all dimensions are the same. So something times something times something has got to multiply to get 512. That number is simply the cube root of 512 because it's the same number. So you can do this on the calculator. It's a calculator paper. You'd get the cube root of 512. It's 8 centimeters. Hence, each of these side lengths is 8 centimeters, the height, the width, the depth. Let's move on to the next type of part of this question, the surface area. Once you've got that, let's try to figure out the total surface area, which involves 6 faces. And let's work out the area of one face first, like we've done before in similar questions from this topic. So let's take this to be, this green bit to be the area of one face. This is obviously a square. A square is simply 8 times 8, 64. If the area of one square is 64 rather, 6 faces would be, therefore, 64 times 6 to give us an answer of 384 centimeters squared. So not a difficult question really, it's just interpreting these two different ideas of volume and surface area in two separate ways. Once you've got the dimensions of a cube, you can simply go into the surface area, and vice versa. I'd like to think you can obviously do surface area to volume as well on a cube. Part B, 30 of the cubes have to be painted. Nikki wants to buy a paint tin, and this paint tin can cover 1 meter squared. Okay, that's the surface area of it. Does Nikki have enough paint? So for this question, we need to do a bit of conversion from a topic called metrics you should have done before. We're dealing with centimeters in part A, obviously, and meters in part B. Let's understand this question first. So let's convert everything into, let's say, centimeters squared. It's probably easier in this case. Now you should know that 1 meter squared equals 10,000 centimeters squared. Okay, we won't explain how we got that. It's in the metrics topic in detail, but vaguely, if you were to look at this just on this case as a very quick reminder, let's say we had a square which is 1 meter. That would be 100 centimeters over here, and this would be 1 meter as well, both of the same dimensions. Hence 100 times 100 would be this area in the middle, which is obviously 10,000 centimeters squared. Okay, which is the same thing as saying 1 meter. Hence, that's what 1 meter is 100 centimeters over here. This is what you should know before, okay, you go into the exam, because this is a basic conversion, which you should know, or you can just do it like we did right now, if you knew how many centimeters were in a meter. Once you've got this information, she has basically bought 10,000 centimeters squared, surface area to cover. Now, one cube requires 384 centimeters squared. Okay, so obviously we would do this. We would times this by 30. We would do 384 times 30. That's the total surface area she would need. 3 at 4 times 30. On the calculator, remember, it's a calculator question over here. We would get an answer of 11,520 centimeters squared. That's how much she actually needs, okay, of surface area to paint all these 30 cubes. She only has 10,000, so no, she wouldn't have enough paint. She needs to go back to the shop and buy a bit more. Hopefully not to buy another paint. She'll be wasting a lot of paint. But you got to figure out this in terms of the question and just therefore say no, okay, and justify it with these answers over here, because obviously 11,520, okay, is greater than 10,000. Okay, and that's the answer for part B over here. Press pause. Try to work out the perimeter of this compound shape ABCD, involving both a sector and a triangle. Press play when you're done. So this question is all about figuring out the perimeter of this compound shape, and we see clearly two shapes over here. We see this sector ADC, okay, not the whole sector in terms of the perimeter, just AD and DC, and you see a right angled triangle and just two parts, AB plus BC. So we need to find out these green bits, all 4 bits, and add them up together. So let's do the first thing first. So let's first of all look at the triangle over here. Step 1, triangle. So obviously AB, we know what AB is. It's going to be 4. Now BC, how do we find out BC? Well, we have a right angle over here. Don't we? We have a right angle. So that allows us to obviously use something called Pythagoras. Now, if we read the question is saying that AB is 4. That's over here. AB is 4. And AB and AC are of equal length. So AB and AC are of equal length. So therefore, we can assume that AC would be 4 as well. So let's write this down, because this looks interesting. It's like a circle, where A is your center of the circle. And this is simply the radius. So this is going to be 4 kilometers as well. We assume AD would be 4 as well, okay, because it would be a whole circle. Anyway, so triangle, 4 squared. We won't go into the nitty gritty of this, of Pythagoras, but A squared plus B squared equals C squared. You know that, so 4 squared plus 4 squared would give us BC squared. 16 plus 16, 32, gives us BC squared. Hence, root 32 would give us BC. So BC would be this. BC would equal 5.657. We go on. Remember, this is the interim answer, so leave the full answer on your calculator, or write down the full answer at this stage. So step 1, triangle, we have BC already. That's done and dusted. Right, step 2, let's look at the sector. Okay. Now the sector is just the arc. We want the arc of, can we see that arc? The arc of DC, okay? So DC is what we want to find out over here. So this would be, you should understand this, it's always the angle, which is 50 in this case, over 360 times pi d. If AD or AC, if both of them are 4, diameter is double, which is going to be 8 pi. So if we do this, we're going to get an answer of 3.491, and it keeps going on. Keep that interim answer. Let's do the fun part and add them all up together. So the full perimeter of this coastal path, 2 bits are really easy. AB plus AD, that's 4 plus 4. Okay. DC is over here. DC is going to be plus 3.491. And BC is going to be this, 5.657. Obviously, use your full answers for all of these. Well, this one and this one on the calculator. Okay, I've just done this to shorten the answer. And obviously, 17.1 to 3 significant figures. This will be your final answer for this coastal path over here. So look back at that. That's how we do this. 17.1 is your final answer. And that would be kilometers. Just to make sure we're on the right track here. Kilometers. Okay, step 1. Step 2. Press pause or write parts A and B down. Simplify these algebraic fractions the best you can. Press play when you are done. So this question is all about, again, your denominators. Let's look at part A. So 4 and 5. Are these unrelated? Are these related? Now these are obviously going to be unrelated. Nothing to do with each other. So we use the camping method over here. Step 1, step 2, and step 3. Very, very easy to do. And let's do these step by step now. 4 times 5, that's 20. We'll create our denominator over here. Now, the next one obviously is this. Write each step by step, by the way. Don't try to skip steps, okay? 5, 3x plus 1. That's part 2. And part 3 is the minus 4. 2x minus 1. That's part 3 over there. So, let's expand these brackets over here. The first bracket, let's do it like this. 5 times 3. 5 times 1. Now this minus is attached to the 4 over here. We like to think it like this. So it's minus 4 times 2x and minus 4 times minus 1. If we do all those 4 terms and numbers, we get 15x plus 5 minus 8x plus 4. The main misconception is this minus over here. Most students don't understand this minus, but please be aware of that, okay? They write minus 4 at the end, but this should be plus 4 like we have done over here. So the last step, obviously, we put everything over 20, and we're going to simplify the numerator over here. So the final answer is going to be 7x plus 9, and all over 20. And let's just highlight that for you over here. Okay, let's do now part B. So again, are these related or unrelated? Let's look at these denominators. 2 minus x, and you've got x. So these are obviously unrelated over here. So if these are unrelated, what you've got to do is you've got to do this. Let's write a bracket first of all, because we have a number and a term over here, 2 things there. And we're going to, let's write it over here in fact. Let's multiply them together. So this is the camping method over here, because they're unrelated. So step 1, step 2, and step 3. Okay, and on top, let's write steps 2 and step 3. So step 2 is 5 times x, and this one is 4, 2 minus x over here. So this simplifies to give you 5x minus 8 plus 4x, and that's all over the same denominator over here, which is going to be x, open brackets, 2 minus x. The final answer is going to be 9x minus 8 all over x, 2 minus x. Question 2, core 2. Press pause, write part A and B down, simplify these algebraic fractions, press play when you are done. So the first thing we look at are your denominators. So let's look at part A. And let's look at 3x squared and x over here.